How are you doing today? Right, we're going to look at word problems. We're looking at exercise 17.08. I've got a method here. Often it's going to help to draw a diagram. That's the first thing. Make a formula. Sometimes you need to make two formulas and combine them. You always rearrange it so it equals 0, so then you can factorize it, then solve it. Then check the equation again, make sure you've answered the question correctly. Then verify your answer, it should solve the problem. So I'm going to do two examples in this video. The first one, we've got this rectangle, it's 3 centimeters longer than the other. Well, I don't know how long those sides are, so I'm going to call that this is going to be x, and this is going to be x plus 3. Now we're told the area is 50 centimeters squared, so that's base times height. So we've got x plus 3 times x equals 50. We expand that out, which is x squared plus 3x. Move the 50 to the other side to make it 0, because we wanted that this step up here. Rearrange so it equals 0. So when we do that, we've got our formula equaling 0. Now we can try and factorize that. It won't factorize nicely, so use the quadratic formula, or you can use your calculator. Either way, stop the video and do that now. So by using your quadratic formula, you find that x equals 5.73 or negative 8.73. We don't use negative answers, so we can forget about that. Now let's go and check it in the question. If this is 5.73, then this must be 8.73. So check, does 5.73 times 8.73 equal what the question asked us to find it was? That gives me 50.0229. Well, it only asked us to 2 decimal places, so that's about 50 meters squared. I know I've done it. Check, what does the question say? The question asks us to find the shorter side correct to 2 decimal places. Well, the shorter side is not 8.73, it's 5.73 centimeters, hopefully. So let's go back and check what was the question saying. It is in centimeters, yeah. Right, so that's that bit done. Now we have a look at the next question. We've got a rectangular swimming pool that measures 13 by 5. It's completely surrounded by concrete. So this length here at the top and 5 at the top, and 13 down the side. Now if you've got a path there, the path there is going to be x meters wide and x meters wide there. And same here, the path is going to be x that direction as well. So the whole length at the top is going to be 5 plus 2x, and the whole length down the side is going to be 13 plus 2x. So if we want the area of the concrete, pretend it's all concreted. So we would have the area of the concrete, if it was all concreted, it would be 5 plus 2x. That's include the water, and that's 13 plus 2x. And then you take away the area of the pool, which is 5 times 13. So you're going to expand that. That is what the area equals, which is given to you as 78. So we expand that, and then we calculate what we can find for that. So by expanding it out, we see it's 65 plus 10x, etc. We bring the 78 over there. Now we use the quadratic formula to solve that, or use your calculator, and you'll find that x will equal either 1.81 or negative 10.8. Well, we're not going to have a negative length for the path, so 1.81. So go back and check it. Does, when you put 1.81 instead of x there, does it all equal 78? Go ahead, check that, and you'll find it does. So there's the length of the path, and you should know that you have that correct. And talking about swimming pools, how would you like that on your front lawn, out your window? Pretty cool, eh? Looks somewhere like Greece. Certainly not my house. Anyway, I hope that was helpful.